Most of the models suffer from a problem called overfitting. Overfitting is the result of putting too much hard work into building a model and reducing the error rate or increasing the accuracy. So what is the problem of overfitting? So in search of the best model on the given training data, we add as many predictors as possible. We add so many interaction terms, transformations, derived variables, indicator variables, dummy variables. We do so many things just to reduce the error, and every time the error on the training data is reduced, we feel so happy, and we go ahead, try to do or include many more variables, so complicate the model by knowingly or unknowingly, and finally end up with a model which is very complicated, very complex, but still the error in that model is less. By error we mean to say the training error is less. So most of the times we do succeed in reducing the training error. So once the training error is reduced, in fact if we do enough or if we add enough complications, we can even reduce the training error to 0. But is that the best model? What about the test data? Did we do test error? I mean, while building the model, if we are not taking care of the, or if we are not at all looking at the test error, then we might end up with a problem called overfitting. So imagine there is a training data. I take 3 random samples, sample 1, sample 2, sample 3. If I build a model on sample 1, M1, then I got few parameters, or I got a result few parameters, theta 1, theta 2, theta 3. And if I build a model on sample 2, the parameter or the result should be similar to that of on sample 1, because these two are random sample. Both of them are true representative of the population, that is training data set. The model should not really change. But if we are putting lot of effort to reduce the error in model 2, then the parameters might be different, and we tend to fit the best model that will suit just for that particular sample that we have chosen. So the model is just really best for sample 1, M1. So M2 is maybe M2 might do really good only on sample 2. It is just a perfect fit for sample 2. M3 might be just a simple perfect fit for sample 3. So this phenomenon is called overfitting. The model is made really complicated. In fact, the model is very sensitive to minimal changes in the data set. Even if we change simple values, the whole model might get really changed. So the model is really complicated. There are so many parameters in the model, but the training error is near to 0. So that is the problem of overfitting. So the model tries to fit irrelevant characteristics in the data, because there is no real generic trend, but still the model will try to fit a model for and find out that pattern also, because we want the error to be really near to 0. There might be certain amount of accuracy that is present in the data or the model. We still want to push it further and even increase the accuracy, reduce the error, then the model tend to overfit. So generally overfit model is really good on training data, but when you look at the test error, it will fail. So it is not so good on test data. So if a model is really working well on your training data and it is not working well on your test data, then that is called overfitting. We fit the model for the noise in the data, so there is some randomness in the data. We did so many things, we complicated the model so much that we even fit that noise in the data. So the less training error, 0 training error, high testing error is the phenomenon of overfitting. The model is over complicated with too many predictor variables. The model need to be simplified. It's okay to increase the error. So these are the models with lot of variance. They are perfectly fit for the sample data that is there in our hand. If we change the data slightly, then the model changes hugely. hugely. So these are the overfit models, and they have lot of variance. Let us see some of the models with huge variance.